All right, let's take a look at the homework that you did in your last or for the last lesson, page 90, numbers 1 through 12. So if you get your homework out, turn your books to page 90. I think it's 1 through 21. I'm dyslexic. 12, 21, same thing. All right, so page 90, numbers 1 through 21. If you're watching on YouTube, you notice the room looks really different. We are on Zoom, so the quality probably looks a little less as well, but I can actually communicate with my students. So I'm looking forward to this as opposed to just YouTube. All right, number 1, you're adding together scientific notation numbers. What did you get for your answer on number 1, Lana?
8.1 times 10 squared.
Excellent. 8.1 times 10 squared. You have to have the same scientific notation, same powers of 10. We had the same powers of 10. Add them up and then keep the same power of 10. Number 2, what did you have, Joshua?
9.3 times 10 to the 5th.
Excellent job. Number 3, what did you get, Scott? You may have to type it in the chat. Your microphone's very muffled. I'm trying to figure out how to type it in the chat. That's the fun part. Okay, Lana, let's go to you. What did you get for number 3?
1.2 times 10 to the negative 3rd.
Very good. Number 4, Joshua, what did you get?
1.3 times 10 to the 7th.
Great job. Tell you what, number 5, I'm going to go to Lana. Number 6, Scott, go ahead and start typing your answer for 6 now. Lana, what did you get for 5?
5.9 times 10 to the 9th.
Excellent. And then number 6, let's see if Scott can put that up there. Just use an X for the times, and you can just put the number right after 10. So if you put like 105, I know that meant 10 to the 5th, for instance. Instead of trying to figure out how to put an exponent on there. Or you can type it all the way out, 1.6 times 10 to the negative 7th. There we go. Great job on number 6. All right, number 7, 2 types of bacteria were being studied. The first type was 4.5 times 10 to the negative 5th inches long. And the second type was 3.2 e negative 5 inches long. What's the difference in lengths of the bacteria? And Joshua, what did you have to do in order to solve the problem?
Subtract.
And when you did, what did you get for your answer?
1.3 times 10 to the negative 5th.
Excellent job. Number 8, you were writing the numbers in scientific notation. Scott, give me letter A while he's typing Lana, letter B.
Oh, wait, number 8 or number 9?
8.
Oh, 4.8 times 10 to the negative 5th.
There we go, 4.8 times 10 to the negative 5th. Going back to letter A, Scott typed it up, 7.7 times 10 to the 6th is correct. And then for letter C, Joshua?
3.5768 times 10 squared.
Excellent job. Number 9, writing each of these in standard form. Again, Scott, you type A. Lana, give me B.
Oh, 0.00025.
Good. Scott has A up there, 419.32 is correct. And letter C, Joshua.
470 million.
Well, that's a 1, not a 7, but I think you meant 410 million.
Oh, yeah. My one's just off to the side a little bit.
There we go. 410 million is correct. Number 10, this is what we were working on yesterday, where when you add them together, you end up with 2 digits perhaps, or 3 digits or something like that before the decimal. Or maybe you don't have any digits after, you don't have a digit before the decimal, and you got to move that decimal one direction or the other and then change that exponent of 10. Number 10, what did you get, Lana?
1.32 times 10 to the 5th.
Excellent job. Initially 13.2 times 10 to the 5th, but becomes 1 or times 10 to the 4th. She moved it over 1 place to get 1.32 times 10 to the, bump that exponent up, 5th power. Scott, type your answer to number 12 while Joshua gives us his answer to 11.
1.42 times 10 to the 6th.
Excellent job. Once again, we ended up with 2 digits ahead, move it over 1 place in front of that 4, bump the exponent up 1.42 times 10 to the 6th. Scott ended up with 6 times 10 to the 1st power, initially 0.6 times 10 squared, but since you had to move the decimal over 1 place backwards, since it was such a little number, you had to drop the exponent down to a 1. Number 13, Lana.
8 times 10 to the 5th.
Excellent job. Same thing. It was 0.8 times 10 to the 6th. Move the decimal back and therefore lower the exponent. Number 14, Joshua. 15, Scott. Start typing.
2.2 times 10 squared.
Just a little addition error on that one. When you added the 6.2 times the 5.8, gives you not 2, but 12. So 1.2 as you move the decimal over the 1 place. But you are correct in that it is 10 squared because we're going to bump the exponent from the 1 up to the 2. So 1.2 times 10.
16 for some reason.
I'm sorry?
I accidentally put 16 for some reason.
Ah, I got you. Maybe the parenthesis looked like a 1 to you or something.
Yeah.
Number 15, Scott's got his answer up there. 1.66 times 10 to the 3rd, or 10 cubed, is correct. Looking at some of the review exercises now in the blue lettering. 38 feet, how many inches, Lana?
456.
Great job. Number 17, 11 pounds, how many ounces, Joshua?
176.
There we go, 176. I was about to get you too. Number 8, you knew it because I always get you. Except you've been getting yourself the last couple times, so good job. Number 18, Scott, how many liters in 25 kiloliters? 25,000 is correct, though you'd help me a lot if you use a comma. Number 19, Lana, when you multiply 1 pound 3 ounces by 8, you end up with what final answer?
9 pounds 8 ounces.
Very good. Number 20, when you subtract, what did you get, Joshua?
4 feet 10 inches.
Great job. And number 21, Scott, when you added those two mixed measures together, you got 40 feet 10 inches, and that is correct. Great job on that. Any questions on the homework? Was there anything that any problems you needed to see worked out? Any that you say, I missed it, could you please show it worked out on the board? Going once, going twice. All right, let's go and review some things then from really this whole quarter, because the quarter exam coming up on Tuesday in lesson 41, we'll cover everything we've covered so far this quarter. And we began the year by talking about adding, subtracting, multiplying, and dividing. Tell you what, just call it out, or Scott, you can type it out. What do we call the numbers that get added together in an addition problem? Anyone, this is call it out. I think I can tell. Yep.
And yeah.
Add-ends, good, Joshua, add-end, and I see it there from Scott as well. What do we call the answer to the addition problem? Some. I think I heard Lana just a hair ahead of Joshua there. In a subtraction problem, what's the answer called?
Difference.
Difference, good, Lana. You're at a disadvantage here, Scott, because you're trying to type it. What do we call the top term in a subtraction problem?
Minuend.
Minuend, good, Joshua. And the lower term, of course, that would be?
Subtrahend.
Subtrahend, good, Joshua. When you multiply, what do we call the numbers that are multiplied together?
Products.
Well, that's going to be the answer to the multiplication problem. Good, Scott got it. Factors. Yeah. Factors. Of course, you can multiply multiple things, right? You don't have to just have 2. You can say 3 times 4 times 7 equals 84. Well, here we actually have 3 different factors, don't we? So you can have multiple factors. Of course, the answer Josh already gave us was the product. And if you had multi-digit multiplication, you would end up with partial products that would have to be added. In a division problem, what do we call the answer?
The quotient.
Quotient, good, Joshua. What do we call the term in the division house?
Dividend.
Dividend. It's also the first number listed, like an 8 divided by 4. This would be the dividend. Also 8 divided by 4. Or what's another way we could show division?
With the negative exponent.
With the fraction bar.
Oh.
Or technically, Joshua, if you said 8 times 4 to the negative first. That is showing division, isn't it? Because you're
Yeah.
multiplying by a reciprocal. So that's actually really clever. I did not see that one coming. Good job. But I was thinking fraction part. But in any case, this is the dividend. What would the 4 be in every case?
Divisor.
A divisor.
Divisor, the number that is being divided out. We talked about fractions, speaking of which, we said the top number in a fraction is referred to generally as the
Numerator.
numerator. Of course, the lower number class is the
Denominator.
denominator. But that's in a fraction, right? If I were making a comparison, for instance, of 5 to 2, maybe we said that, I don't know. Let's say that Lana got 5 points at PE in the batting base running drill that got suspended temporarily because of the shutdown. And let's say that Scott had 2 points in the batting and base running drill. Then we would say the ratio of Lana's points to Scott's points is a ratio of 5 to 2. And we would not write this as 2 1/2. Remember, with ratios, you just leave it as the improper fraction. But when it's a ratio, we have a name for this first term. It's not called the numerator anymore. What do we call it? Good, Scott, that was quick. You saw this one coming. I think the antecedent and the lower term would be the
Consequent.
Oh, yeah.
good consequent. And if we were just adding, for instance, we said, what is 7 1/2 plus 3 1/2 plus 5 1/2, and we ended up getting 5 halves down here. That's where you make it 2 1/2, right? Carry the 2 and so on and so forth. We have to have a couple more halves to make that happen. But with the ratio, remember, you leave it, quote, improper. Even if, let's suppose we had a ratio of 8 to 4. Maybe Scott has 8 points and Joshua has 4 points. Well, the ratio is 8 to 4, but we reduce it down, Joshua, to
4. Wait, 8 to 4.
What could you divide out of both the antecedent and the
2 over
2 over
1.
1? But you wouldn't just say 2, remember, in a ratio, you'd leave it as 2 to 1 or 2 over 1. By the way, there's a couple other ways you could write a ratio. Let's go back to a ratio of 5 to 2. The fraction is the best way, easiest way to write a ratio. What would be another way to write this ratio, Scott? Want to type one of the other ways in the chat there? Good, you can use a colon, 5 colon 2. What about the last way, Lana?
You put 5 and then you spell out the word 2.
Good, 5 to 2. So 3 different ways in which we could write ratios. Now, if we had 2 ratios equal to each other, for instance, we said the ratio of 5 to 2 is the same as the ratio of 15 to 6. That's a true statement, right? Because if you multiply both of these by 3, you get the new ratio of 15 to 6. So they're the same ratio. What do we call this equality of 2 ratios, anyone? Good, Scott saw this one coming as well, proportion. That reads really fast at typing. And I don't remember it being quite that fast last year in computers. Good, and proportion. And we said that these 2 terms in the proportion are the second and third terms. What do we call those terms?
The
Good, Scott, the means.
Oh,
The means. And so then these terms would be class the
extremes.
extremes. Good, the first term and the fourth term. And remember, we said that in any proportion, the product
Of the means equals the product of the
equals the
extremes.
product of the extremes.
There we go. Good. Scott, I can hear you answering. I'm just picking on you. Anyway, that's a lot to type out. Good. Go and turn to page 135 now. Turn to page 135 in your textbooks. And I want you to do numbers 1 through 12 on page 135. Real quick, one more thing I meant to ask before you get started on that assignment. With a proportion, if we were missing a number here, and now here again, you can see dividing the 3 to get the 2 really easily, but if this were something weird like, I don't know, a 13 or something strange, how would you solve a proportion if you couldn't see equal ratio method easily?
Change it into an equation.
Right, by doing what? Because the product of the means equals the product of the extremes, we can
Cross multiply. Yeah.
cross multiply 13x equals 30 and go from there, right? All right, now doing numbers 1 through 12 on page 135. When you're finished, just mention in the chat that you are finished. All right, I see that Scott is finished. Scott, just wait patiently while the others finish up. Going to be finishing up in the next minute or two. Just a little bit longer to be finishing up. And Lana, which number are you on?
Well, I just finished. I forgot to.
Okay, good, awesome. Just finished. Joshua, which number are you working on? Joshua? Hey, which number are you working on?
11.
On number 11. Okay, so you're right there at the end. Let's go ahead and go, for sake of time, go ahead and go over these because I want to make sure we get all the review in that we need these 2 days, today and Friday or on Monday. Number one, main thing is keep the decimal lined up. Lana, you got?
63.3.
Excellent. Number two, again, keep that decimal lined up. Joshua, what did you get?
2068.033.
Really close. Scott, what did you get?
Oh, wait, nah.
You find it? Yeah, 2078.033. Just a little borrowing issue there.
Oh, just an error in it.
Yeah, let's go back to you for number three there, Joshua.
204.8.
Good, just one decimal place in that answer. Excellent. Number four, Lana, doing some long division here.
582.
Excellent, came out evenly to 582. Number five, the important thing is to get a common denominator. And your common denominator, Scott, should have been 56. Good. So when you add it together, you wind up getting an improper fraction. You make it a mixed number, get 1 and 27/56 should have been your answer. For number 6, what was your common denominator, Lana?
45.
45. What did you get for your answer on number 6, Joshua?
Um, 5 and 14/45.
Good. 5 and 14/45. Number 7, see if you can type it in the chat there, Scott. Maybe use a slash for your fraction bar to space between the whole number and the fraction. And number 7, he got 2, not 2 and 20/27. Joshua?
3 and 4/27.
Ooh, no, Lana?
2 and 10/27.
It should have been 2 and 10/27. So let's take a look at this together real quick. We want to cancel wherever we can, right? Reducing in a sense. Notice they already gave you a gift in that they made this improper for you. You didn't have to turn a mixed number into the improper. In fact, both of these, they started out improper fractions. So we cancel a 3 out of both of these to get 8 and 9. I see a 5 in both of these to get a 3 and 8. And again, you'd love to cancel the 8s and the 3 with it, but you can't cancel, right? And I think we all did a good job of leaving that 64/27. Keep in mind, 27 goes into 64 2 times, but if you multiply by 2, that's 54. So goes in 2 times, and if it equals 54, that means there's going to be 10 left over there. For redemption, Scott, number 8. One-ninth is correct. How about number 9 for redemption, Joshua?
28/45.
Great job. And in both cases, multiplying by the reciprocal. Good. Number 10, Lana.
1/24.
Good. 1/24. Number 11, Joshua, was the one you were working on there at the end.
10.
10. And number 12, Scott. 57 is correct. Questions on any of those? Do we need to see any others worked out? All right, let's do some more review and just a second. All right, let's do some more review here. And I want to review over different types of numbers, different ways in which we classify numbers. First of all the numbers that we're going to focus on for the next several years, we call real numbers. But within real numbers, there are two broad categories. One refers to numbers that can in some way be written like a fraction or a ratio of two values. Any number that can be written as a fraction or a ratio of two values is called anyone?
Ration.
A rational number. Good, Joshua Scott as well there in the chat. Even a number like 0.78351, because you could write it as that many 100 thousandths, right? So remember we said any decimal that does eventually terminate, that does eventually end, is rational. Even repeating decimals, like for instance, 0.7 repeating. Well, what fraction would that be, by the way?
Not 7/9.
Or 2/7.
7/9. By the way, if it were 0.72 and both digits repeated, it'd be 72/99, which reduces down to 8/11. So if you have multiple digit repetends, you just put it over 99. If it's 0.725 and the 725 repeats, 725 999. Now, you don't have to know that, so don't be terrified by it, but just a little cool little fact. You use a denominator of 9 for every digit that's repeating, as long as they're consecutive repetend digits. But anyway, repeating decimals can all be turned into fractions, so they're rational numbers. So fractions, of course, are already fractions, so they're rational. Whole numbers like -8, well, put it over 1, now boom, it's a fraction. So what kind of things aren't rational?
Counting numbers.
Well, those are rational. Okay, irrational. I was looking for examples of irrational numbers, but thank you, Sky. Yeah, irrational numbers are not rational. What would be, okay, pi is irrational, right? Because it doesn't ever end, it doesn't ever repeat, so it's irrational. What other number might not ever end or repeat? Roots. Roots that don't work out evenly, like the square root of 2. Now, the square root of 4 is even, right? That's 2 over 1. But the square root of 2 doesn't work out evenly. The fifth root of 8. You can't work that out evenly. So most of your roots are irrational. Pi is irrational. But most of the numbers we work with are rational. That said, some of our rational numbers are really ugly, like the 0.78352, or even the 0.73 repeating. Like those are kind of ugly, or 5 17. That's kind of ugly. I like nice, easy numbers. And what term refers to the nice, easy numbers?
Counting the
Counting numbers are your positive, easy numbers. But what about like negatives? It's really -7. Is
whole.
No.
Integer.
Integer. There we go, Lana.
Oh.
Like you're there on the screen, but you're all right. Nice. Integer. So remember, an integer means a nice, easy number, like -7 or 4 or 13 or -12. There's no fractions, no decimals. We like integers. Now, if we cut the negatives out and we had only the positives and maybe 0, what do we call those? Good, those are the whole numbers. Good, Scott. But if we even took 0 out and we literally just had the positive whole numbers, not 0, now we'd have counting numbers, or the book calls them
positive. Wait, not that.
natural numbers.
Oh, it's been so long.
It has, so that's why we review, because it's been forever. Joshua actually helped us review this a moment ago when he mentioned a negative exponent. But what does a negative exponent mean, class?
Division. Wait.
Well, it can be used to show division if you multiply by a negative exponent, but in general, negative exponents, Lana, mean
Wait, reciprocal?
there we go, reciprocal. Good.
Reciprocal?
Yes, reciprocal. So if we had 7 to the -2nd, how could we write that? What's another way to write that, Joshua?
1/7 squared.
Good. And what is 7 squared?
49.
So in other words, 1 over 49.
49.
Had a 1 over 5 to the negative third. How could we write that, Scott? Five cubed, very good. And what is 5 cubed, anyone?
125.
Good job, Joshua. 125. I think you might maybe a hair ahead of Scott. Good job on that. Fractions and decimals. We need to know these, okay? Every year, my students in Algebra 1 struggle because they don't remember fraction decimal equivalents. And oh, what a blessing it would be to remember these. So let's go ahead and drill here. And I don't know that we can do quite the same level of review game simply because of, you know, the virtual nature here. But, you know, you can have pride, right? If you realize you get lots of these, then you can have a little bit of self-pride here. Not that pride's always a good thing, but yeah, it's not always a bad thing either. All right, so give me your decimal equivalent.
Oh, that one? 0.6.
0.6, Joshua with the point.
0.6.
0.65.
Good.
0.65.
0.3 repeating.
Good.
0.3 repeating.
Good. Lana's right there.
Point. Wait, whoa.
0.4 repeating.
Good, Lana.
Oh yeah, that's
yeah. Okay.
I was gonna say that, but
yeah, Lana, your computer's lagging, so you're actually a few seconds behind us, but I know you're right there with us. And that time you beat him out even with the lag.
0.125.
0.125.
Good.
0.75.
0.75. I see you answering there, Scott.
0.2.
There we go. Scott actually beat you that time, Joshua.
0.83.
0.83 repeating.
0.83 repeating, Lana.
I say 0.16 repeating.
Good. 0.16 repeating.
0.8.
0.8.
0.25.
Good. Just a hair ahead of you, Scott.
0.4.
0.4. That was a tie.
0.875.
0.875.
Lana with the 0.875.
0.6 repeating.
0.6 repeating, Joshua.
0.375.
375.
0.5.
0.5.
0.6.
0.6. There we go. All right. So now let's go the other direction now. I think Joshua is winning right now, though he does have a little technological advantage in that his audio doesn't lag and he doesn't have to type it in the chat, but still, good job, Joshua. Take him out and get him, man. It's not your fault there's a handicap, right? All right, so here we go. We're not starting with this one, starting on the next one.
Oh.
1/3.
1/3. Okay, Lana's lag is definitely gone. She is right there with us now. Good job, Lana.
5/8.
5/8. You got as far as the 5 fraction bar. I never got the 8 there, Scott.
5/6.
5/6,
Yeah.
Lana.
2/5. Wait,
1/2.
1/5.
God.
Wait, no. What? I knew it's just hard going that way.
The pressure.
1/5.
1/5.
1/5, Lana. You're hitting your enter key too quickly, Scott. You missed that last digit. Make sure you finish the fraction before you enter.
3/4.
3/4. There we go, Joshua.
1/4.
1/4, yes.
3/8.
3/8.
4/9.
4/9. There you go, Joshua.
2/5.
2/5. Got that time.
4/5.
Oh yeah. 1/6.
1/6. There we go.
2/3. Wait, no, 2/5.
3/5. Scott.
2/3.
That's 2/3, but Scott again.
1/8.
8. There we
Yeah.
go, Lana.
7/8.
7/8. Good, Joshua. All right. So make sure you know those. I feel like we've got a good handle on those, and that's a very good sign moving forward. We talked about numbers that only have 1 and themselves as factors. What do we call these numbers that only have factors of 1 and themselves?
Prime.
Prime. Good. That was unison. Even the screen popped up at the same time with the chat. Prime numbers. And let's say our prime numbers together between 1 and 20. 2,
2,
3,
3,
5,
5,
7,
7,
11,
9, wait, 11,
11,
13,
13,
17, 19.
Yeah, it's hard because we're all in slightly different lag times there, but there we go. 2, 3, 5, 7, 11, 13, 17, 19, your prime numbers. And we use these to break other numbers, composite numbers. Thank you, Scott. I saw that down there. To break composite numbers into smaller parts or to factor. So if we had, for instance, the number 45, I could prime factor this by dividing it, Joshua, by
2, wait, no, 3.
There we go.
15. 3 again. And then 5.
There we go. Or if we had the number 72 on, another way is we can just pick any two random numbers to split it up into. Lana?
Wait.
What are two factors? Just any two factors, not even prime.
Wait, 8 and 9?
There we go, 8 and 9. We can split the 8 into
2 and 4.
and the 9 into,
3 and 3.
but we see that the 4 still splits one more time.
2 and 2.
So we see our prime factors of these two numbers. Now, if I wanted to know the greatest common factor of the two numbers, I'd have to look for what's actually shared. And Scott, which factors are actually shared? 3 and 3. So my greatest common factor is 9. Very good. If I want to know the least common multiple, I'd have a contest. And I pick the winners. And the winner of the twos, Lana.
The 72.
Right, all three of these. In fact, it's a winner by default, right? Because this one didn't even try. What about the winner of the threes, Lana?
The 45.
Good. You were about to say it was a tie, and you're like, no. He said if it's a tie, just pick one. Great job. This is the loser. She has so spoken. She has ordered it, and it shall be so. The 45 is the winner. Of course, by default, the 5 wins here. So 2 times 2 times 2 times 3 times 3 times 5 ends up giving us the least common multiple of 360. Give me just a second. All right, let's go ahead now and review over percents. And of course, we said that percent means
Hundreds.
hundreds. Good, Lana. Percent means hundreds. So in other words, anytime we make a decimal into a percent, we have to move the decimal how many times, class?
Twice.
Twice.
Good. If we want to make a percent into it or a percent into a decimal, we have to move the decimal how many times?
Twice.
Twice again, right? We always move the decimal twice. You know, the little acronym, if you will, D2P. You go into a percent, you move it twice that way. If you're making it a decimal, you move it twice that way. But if you're making a fraction into a decimal, you want to get a denominator of
Wait.
100.
100. So for instance,
Oh.
if you had 3/25ths, you could multiply top and bottom by 4 to get 12 hundredths, which would be 12%. But if you wanted to make a percent into a fraction, you would put it over
100.
100. It's the same thing.
Yeah, if you had 78%, you would make that 78 100ths. And of course, you'd reduce down to get 39/50ths. But everything revolves around either two decimal places or denominators of 100. Now, we have this, if we said 7 is 25% of 28. We said that obviously this is our percent. It's obvious because you see the percent sign. We call the 7 our what? Our percentage.
Oh.
Percentage. And the 28 is called the
Base.
base. Good.
Base, yeah.
I didn't emphasize that these terms very much because frankly, the terms are not quite as important as knowing how to work with them. The key to remember is that the word is means
Equals.
Equals.
then a percent should always be written as a decimals with how many decimal places?
2.
2. So 0.25. And then of means
Multiply.
multiply. So we could say that 7 equals 0.25 times 28, where if I didn't know the 28, I would call it,
X.
and then to get the x by itself, I divide both sides by 2 or 0.25. If I knew the 28, but I didn't know the 7, well, then I would call this spot here.
X.
All I'd have to do is multiply, right? And then if I didn't know the 25%, then I would make that x. Or here,
X.
by 28. And I could go from there. Okay, so all of that. I want you to practice now, pages 135 to 136, numbers 13 through 24. Pages 135 to 136, numbers 13 through 24. We got started just a couple minutes late, waiting for everyone to get in on the Zoom meeting. So I'm going to go a few minutes past the bell so we can go ahead and finish up this assignment. So in a moment, you'll hear the bell ring. Just keep on working. I did want to mention, though, on Monday, you need to make sure you're here on time because I can't go over. Whatever we get covered has to be it. On Monday, I want to make sure that we get the full review in. But if you're running a little bit late getting in, then we may not get everything covered, but we've got another Zoom meeting that's meeting in this room right after me. So I have to end on time on Monday. So try as best you can to be here before 12:20 in the Zoom session so we can start right on time. Okay. Go and keep working though for now. When you finish, be sure to leave a comment about that. All right, Scott's finished. Take a few more minutes to be finishing up. We'll have one more minute and then we'll go over the answers to these. Looks like Lana's finished. All right, Lana, you finished?
Yeah, I'm finished.
All right, and Joshua, are you finished?
I'm finished.
All right, good timing. Let's take a look at these. Number 13, which of those numbers could be labeled as an integer? Joshua?
0 and 22.
Very good. 0 and 22 would both be integers. Nice, easy numbers. Negative 4.5 is rational, but not an integer. 2/5 also rational, but not an integer. And pi would be irrational. Number 14, what's the decimal equivalent of 2/9, Lana?
0.2 repeating.
Good. What about 1/8, Scott? 0.125. And then also, Scott, what about 17/40ths? 0.425. Very good. Had to actually do the division on that one, didn't you? 17 divided by the 40. Remember, the top dog goes in the house. And then add some decimal places to give yourself room to do it. So you end up with a 0.425 by the time it's all said and done. Number 15, Sanford has 11 pencils, 10 pens. What's the ratio of pens to pencils? Joshua?
10 to 11.
Very good. Read correctly. Not 10/11ths, but 10 to 11. Excellent job. Number 16, Juanita owns a furniture store. She sold 6 couches and 20 recliners last month. What's the ratio of couches sold to total pieces of furniture sold? Scott? Three to 13. Very good. 6 to 26, but reduced down to 3 to 13. Number 17, if a car company gives 20% employee discount on a truck that costs $30,000, what does it cost an employee to buy the truck, Lana?
Oh wait, 6,000.
Well, that's the amount of discount, right? So it was a $30,000 truck that is on sale there, but employee saves 6,000, right? Because he saves 20%. So if he saves 6,000, how much does he have to spend?
Wait. So do I add or
You just subtract, right? Because savings is the amount you have to pay.
Yeah. So I can do this. Oh, it is 24,000. I
Is much he'd have to spend. Number 18, last year, tickets to the zoo cost $14. If tickets cost $16 this year, what's the percent of change to the nearest whole percent? And is this increase or decrease? Let's go back to Lana for redemption. What did you get?
Wait, 14%, and it's increase.
Very good, 14% increase. Remember, put the change 2 over the original, and when she divided it out, 0.142, blah, blah, blah. 2 did not bump it up, so rounding off to 14% increase. Great job. Number 19, what's the greatest common factor of 50 and 65, Joshua?
5.
And what about the least common multiple?
650.
Great job. Number 20, what is 5 to the negative third written with positive exponents? Well, we've seen this one before, haven't we, Scott? What do we get? One over 5 cubed, or 1 over 125. They said positive exponents. Good. What about 1 over 3 to the negative fourth written with a positive exponent, Lana?
3 to the 4th over 1, or just 3 to the 4th.
Very good. If you worked it out, 81 is what you'd get. Number 22, what's 30.5% of 90, Joshua?
27.45.
22 is what percent of 200, Scott? 11%. And the number 24, 42 is 70% of what number, Lana?
60.
60. Any questions on any of those? Any questions? Any you need to see worked out? Going once, going twice. All right, your homework for this evening, or for the weekend, I should say, is to do page 137. Page 137, the homework section, numbers 1 through 6, 10 through 12, 15, and 16. Page 137, the homework section, numbers 1 through 6, 10 through 12, 15, and 16. Your quarter exam will be over chapters 1 and 2, and that'll be in lesson 41, which is on Tuesday. All right, have a wonderful rest of your day. You are dismissed.